So good evening, everyone. I think it's time to stop. It's time to start. I think you all hear my voice clearly. Before a guest lecturer is going to start the course, I want to give some information about this week's topic. As we told earlier, fire is very important in our even daily life and in our professional working life. So as a member of the family, as a driver or as a worker, we should know about fire. And on the previous week, we talked about basic fire knowledge. And this week, we are going to talk about fire-related topics, which are also related to our profession. So we have a guest lecturer, Mr. Yusuf ARSLAN. Before introducing him, I would like to thank TÜYAK, Türkiye Yangından Korunma ve Eğitim Vakfı, Turkish Fire Protection and Education Association, I think. I hope it's the correct translation for the name of that association. And this NGO, Sivil Toplum Örgütü, plays a vital role about the fire protection issues in Turkey, just like the NFPA in United States. As we told earlier, NGOs played a pioneering role in the development of the fire protection or fire suppression or fire safety sectors. You can check the social media websites addresses of TÜYAK on Facebook, on LinkedIn, and also on YouTube. Also on the YouTube page, you can find recordings of some webinars and have some extra information. The website is TÜYAK.org.tr. You can visit it. And the lecturer today is Mr. Yusuf ARSLAN, also a member of TÜYAK. I would like to thank to him for joining us and giving this lecture. Also, he's going to make the presentation in English, and this is his LinkedIn page, and he is working as the technical support supervisor at Viking company for 3 years, and before that he is highly skilled and have some experience in the sector at the different companies. And also he is graduated from Naval High School and Karadeniz Technical University as a mechanical engineer in 2006, and he is a member of TÜYAK and also the American Association, NFPA. So without losing any more time, I would like to pass the word to Mr. Yusuf ARSLAN, and he is going to give the lecture about fire suppression systems.
Good afternoon. Welcome to our course today. I will be talking about, with the first knowledge of fire, what is fire and fire hazards. After that, we will discuss about your knowledge about the systems and systems to extinguish the fires and detection of the fires. Thank you very much for the initial thoughts and information, Gökçe Bey, and I will do my best to convey the technical knowledge and the basic information on how fire protection systems work and in coordination with the detection systems. Today we will talk about first about the definitions of some fire protection systems, and we will cover sprinkler systems and different types of sprinkler systems, foam systems, and gas suppression systems in detail. We will show some operation examples and explain about where they are used and how they work. let's talk about a little bit the standard definitions of fire protection systems. Sometimes we see that the basic and mostly preferred fire protection system in the industry is automatic sprinklers. These are a fire suppression and control device that operates automatically when it's heat activated. So we need some heat to activate a sprinkler, and they have an element upon heating up to some degree, it activates and water discharges over the specified area to control the fire. And this is called the automatic sprinkler. So you don't need any kind of extra detection device because it's already a detection device. It has a heat activated thermal element. And an automatic sprinkler system is with pipes and water under pressure and allows water to be discharged immediately when a sprinkler head operates. So we explained the automatic sprinkler, and when the automatic sprinkler activates and operates, there should be a complete system with pipes and water under pressure behind it to work as an automatic sprinkler system. This is a system definition. And when we talk about detection system, a system consisting of detectors, controls, control panels, automatic and manual actuating mechanisms, all wirings, piping and tubing, and all associated equipment that is used to actuate an extinguishing system. So a detection system is mainly in standard descriptions described as a system to actuate an extinguishing system by manually or automatically. An automatic fire detector is a device designed to detect the presence of a fire signature and to initiate action. This action could be an alarm or operating a fire protection system. And kind of system detectors are fire gas detectors, heat detectors, different types of radiant energy sensing fire detectors or smoke detectors are explained as automatic fire detectors. So we can use these devices to either get an alarm to inform the residents or users of a building that there is a fire. You will hear an alarm, or you will activate some systems that I will show you in the next slides. You can activate these systems automatically or by manually. An automatic fire detection system is a fire detection system that senses the presence of a fire, smoke, or heat and activates a sprinkler system or an automatic alarm system. So this device is completely automatic. It is preset with some adjustment, and when detector device senses the presence of fire, the system operates or it gives an alarm. So it's an automatic system. So we will talk about first widely used sprinkler systems in most of the buildings we have in our schools, in the shopping centers that we cannot visit these days, or in libraries, in different types of buildings. We have always seen the sprinkler systems. These are also fire detection and fire extinguishing devices incomplete. So it's an automatical device that senses the heat coming from the fire, and it operates and extinguishes or controls the fire. So how a sprinkler system works?
Guess who's not getting their shoe deposit back?
Definitely not like this. So we need to know how it works. So we have to be careful as well what we are doing with the sprinkler systems in order to avoid accidental discharges and water damages. So when we look at a fire sprinkler, it looks like a single part, but it's composed of many items. It has different parts to make it a complete actuating device. It has a water hole, it's called orifice, and it's defined by the water flow per the pressure behind the sprinkler, and you have a defined value of K factor depending on increasing with the fire hazard or the installation height. So you have different kind of sprinklers with different K factors, namely the different flow rates of water when you need to open the sprinkler during a fire. If the fire load is too much, the water discharge will be more. So that will be different as a K factor. So that is defined by the size of the orifice, as you see on the bottom of the slide. And there is some kind of sealing material, and the sealing is kept in place with a glass bulb or a fusible link device that activates on a defined temperature. So what is the defined temperature is, for example, for this unit with red color is 68 Celsius. So when it is 68 degrees Celsius, this sprinkler head is, the glass bulb on the sprinkler head is explodes, and the waterway is completely open automatically with the spring mechanism, and the water comes. So this is parts of the sprinkler head and how it works. So we will see a short video now, which is 2000 times slower than the second. So you will see 2000 frames per second. It activates very fast. So again, we will see how fast it's working. So the waterway is open and the water comes and the sprinkler discharges the water to the fire. So this system is starting to work with the heat activation of the sprinkler. And the system components of a sprinkler system is consisting of the alarm valves, the piping system, and the sprinklers on the different parts of the building. So you can see on the ceilings or on the wall sometimes the sprinkler heads. So they are connected between them with the piping, and in the riser that we call the main pipe, we have an alarm valve. Why we call it as an alarm valve? This is a water flow alarm device. So when the water flows through this device, it gives an alarm, mechanical or electrical alarm. So when inside the building a sprinkler operates, you can have a signal electrically or mechanically sounding an alarm to you that there is a fire in the building. So everyone can evacuate the building and the fire brigade comes. So this system is working as an alarm system as well. Without having any detectors, the sprinklers are detectors itself for the fire. So in that schematic, you will see a combined system. So there is a water tank, fire pumps, sectional valves, which are called alarm valves. And if you have a system with freezing temperatures, you have a dry system. So you cannot keep water inside the freezing rooms that is below 4 degrees Celsius. In cold rooms, cold storage areas, you have to have dry systems. And the wet systems are only inside the normally heated areas or normal rooms, not in this unheated or freezing temperatures. So you have here, before the room, all the pipe is empty and filled with pressurized air with a compressor. So this is a dry system. With the dry system, we are avoiding the frost inside the pipe, and the system operation is possible when the sprinkler operates, the air releases from the pipe and the water fills the piping and controls the fire. And there is a detection and control panel controlling all these systems and seeing all the signals from water flows, the alarms, and it's informing the fire brigade from this panel. Also, we have the pump control cabinets in coordination with the flow switch, pressure switch. It's operating automatically and restarted manually. So it's a general system overview. So we will see from now, after this section, we will see some different kind of systems and how they work in actual fire. So we have different sprinkler system types, as you see on the schematic. We have dry system, we have wet systems, and in general, we have, especially in the projects in Turkey, almost in all projects, we have a fire water tank supplying our fire protection system. And there is a fire pump room. And inside the building, we have an alarm valve and sprinkler systems. So there is a complete system consisting of water supply, pump system, and the valve systems. And in the end, we have the sprinklers. But we only see normally in our daily life, the sprinkler head above our head. So when we see the sprinklers from now, we will think about the complete system that should be clearly big investment for any kind of facility. So you remember this schematic. This is a standard wet system, and all the pipes are filled with water. And when the sprinkler operates, the sprinkler discharges the water immediately onto the fire. So we use here wet alarm valves, which is called wet system alarm valves. And these valves are typically a check valve that allows the water flow in single direction on the sprinkler direction. And the target of this using this valve is to get an alarm from the system, also to test the system before the fire happens. So we want the system to inform us when there is a fire happens or a sprinkler operates that should mechanically or electrically gives an alarm to us. So let's see in an animation how this wet system valve works.
A fire has started in the building. As the fire grows and the heat reaches the rated temperature, the sprinkler will activate. Since this is a wet system, water is already in the pipes, allowing the immediate delivery of water to the fire. After the sprinkler activates and water flow is established, the clapper is fully lifted off of the seat and the alarm ports are exposed, allowing water to enter and fill the alarm line. If the system is equipped with a retard chamber, there will be a slight delay as the chamber fills before activating the water flow alarm. The retard chamber is a device that prevents false trips by containing up to a gallon of water flow prior to creating an alarm. Inadvertent water flow will only be able to fill a portion of the retard chamber's capacity. The alarm line is equipped with a 1/8 restricted orifice that allows the retard chamber to externally drain and reduces false alarms. During a fire, a consistent flow of water enters the alarm trim and fills the retard chamber faster than the restriction can drain, and the water flow continues through to the alarm devices. The water will then activate the water flow alarm, alerting the fire department and informing building occupants to evacuate. The water motor gong is installed as a failsafe to any electrical alarms. The sprinklers continue to control the fire until the fire department arrives.
So I will operate again the same animation because it's a little bit fast explanation. So
A fire has started in the building. As the fire grows and the heat reaches the rated temperature, the sprinkler will activate. Since this is a wet system, water is already in the pipes, allowing the immediate delivery of water to the fire. After the sprinkler activates and water flow is established, the clapper is fully lifted off of the seat and the alarm ports are exposed, allowing water to enter and fill the alarm line. If the system is equipped with a retard chamber, there will be a slight delay as the chamber fills before activating the water flow alarm. The retard chamber is a device that prevents false trips by containing up to a gallon of water flow prior to creating an alarm. Inadvertent water flow will only be able to fill a portion of the retard chamber's capacity. The alarm line is equipped with a 1/8 restricted orifice that allows the retard chamber to externally drain and reduces false alarms. During a fire, a consistent flow of water enters the alarm trim and fills the retard chamber faster than the restriction can drain, and the water flow continues through to the alarm devices. The water will then activate the water flow alarm, alerting the fire department and informing building occupants to evacuate. The water motor gong is installed as a failsafe to any electrical alarms. The sprinklers continue to control the fire until the fire department arrives.
okay, this is basically a wet alarm valve by the name. You can see it works as an alarm device. It gives an alarm. Here you have a water motor alarm. It's like a gong. It turns with the water velocity and it gives an alarm mechanically, and it's ringing like a bell. So it gives a mechanical alarm to the building, to the people in the building to escape, and also fire brigade to approach the right place for the fire. So also we have here an electrical alarm device. When water comes here, the electrical alarm is giving to the fire detection panel, and it gives that signal as an alarm, as a secondary electrical alarm. Another application is the dry systems, and we use dry alarm valves in these kind of applications, and it looks like more complicated. So again, I will show you an animation how it works and where it is used. These kind of systems are especially used in the unheated areas and
A fire has started in the building.
Subject to the freezing.
As the fire grows and the heat reaches the sprinkler's rated temperature, the temperature-sensitive device and the automatic sprinkler operates. The temperature-sensitive device could be a fragile ball or a fusible link. Once the temperature-sensitive device operates, either the pip cap or the seal will be displaced by air pressure. Air escapes through the activated sprinklers, causing the air pressure within the outlet chamber of the valve, the trim, and the pipes to drop. If the system is equipped with an accelerator, a sudden drop of air pressure will cause the accelerator to activate, directing air pressure from the system side or outlet side of the dry pipe valve to the intermediate chamber of the dry pipe valve. If the air supply is equipped with an air maintenance device, air will pass through the air maintenance device to the system. As pressure reduces in the outlet chamber, the differential in the valve is equalized to a point that the remaining air pressure in the system cannot hold the clapper closed. The clapper is pushed open by the incoming water supply and then securely latched out of the way. Water flows through the valve and trim piping. The water flow alarms are activated. Water flows through the system, taking the path of least resistance to the open sprinklers. Air pressure will remain trapped in the pipes that are not in the critical path to the open sprinklers. As time passes, water will displace the remaining air and the lines will fill with water. The sprinklers continue to control the fire until the fire department arrives.
So this system keeps the pressure of the water, sprinkler water, inside the pipe with air pressure. The air pressure inside the valve. Second. The air pressure inside the pipe is keeping the valve closed. So we don't have any water inside the pipes in the room. So when the fire started, the sprinkler head is activated. So the sprinkler activated. After the activating, the air inside the pipes is being escaped from the pipe. So the air inside the pipe, air pressure is reducing. When the pressure drops, the system, the valve opens. Inside the valve clapper, inside the valve body, opens and releases the water inside the pipe. As you see on the ceiling, the water passes all the pipes and goes to the open sprinkler, and just above the fire, it discharges the water. So normally before the activation of the system, we don't have any water inside the pipes. So this is called dry system and dry alarm valve. And it's again giving an alarm like mechanical alarm and electrical alarm that the system operated, and it gives information about the system operation. And we have another system called the deluge valves. The deluge valve systems are used in mainly spray systems that we have open kind of sprinklers or open nozzles. That means they don't have any temperature activation devices. All are open, and when you send the water from the main system or main valve, all the nozzles or openings release water at the same time. So not only the activated sprinkler, because we don't have here a heat activated sprinkler, all of them are open, or any kind of different device, nozzle open devices. So the water comes out from all the open items opening on the pipes. There we have an activation, electrical activation panel, and we have a detector system. So electronical detectors like smoke detectors, flame detectors, or other kinds of fire detectors are connected to the activation panel. Here you see the fire extinguishing panel. And the panel activates when you have a fire alarm. The panel activates these 24-volt solenoid that activates and releases the pressure inside the valve and opens it and sends the water to the pipes. And this system also has no water inside the pipes, but also no pressurized air inside the pipe. It's open completely. So it's different kind of a system that I will show you in a foam system example in coming slides. And we have another system called Preaction system. Preaction valve systems are as coming from its name, is pre-action and pre-alarm systems. So when you have, for example, here we see double interlock pre-action system, and when you have this kind of system, the only way you will see water coming from the sprinklers is activation of the sprinkler and the detection both activated at the same time. So for example, somebody hit the sprinkler and we don't have any fire in the room. Somebody hit the sprinkler by accident and it's open. So we have a very important room, historical records or archives or very expensive devices inside the room. So if somebody accidentally hit a sprinkler, there should not be any water coming out of sprinkler by accident, because it will be more harmful than fire to the documents inside or to the devices that we protect. So it should be a pre-action system. When a sprinkler broke accidentally, the system gives you an alarm that yes, here there is a problem, a sprinkler open, but the detector doesn't give us a smoke alarm, so there is no fire. So in order to be a fire, there should be two actions needed. So this is called pre-action alarm valves. So it gives you an information that there is a problem at first, and if there is no there is one of the systems not operated, like detectors or sprinklers, it will not release water inside the room. So this is a pre-action alarm valve system. So it is in general used in also cold storage rooms that requires dry systems. The pipes are filled in with pressurized air, and we don't have water inside the pipes. Just to protect the room, we are protecting the devices or material inside accidental water discharge. So this is kind of a double safety system when you consider about very special and expensive room materials. So these are our different types of sprinklers and spray systems and the alarm valve systems. So they are all in coordination with the alarm and detection systems, but these are the widely used fire protection systems in general in all the buildings that we are living in or we are studying or we are using. So these are the main and widely used protection systems in our life and their relation with the detection systems. So after talking about some water systems like sprinklers and Preaction and Deluge systems, let's a little bit talk about foam systems and where they are used. The foam systems are consisted in different parts, like foam concentrate. So the foam concentrate is basically a soap that we are combining with like a liquid soap. Hand washing soap is a similar material. So we are combining with water with some proportioning. For example, for 3% proportioning, 97 liters of water is mixed with 3 liters of foam concentrate. So it becomes, by using a tank and proportioner, we have a foam solution. The foam solution includes some percentage of foam concentrate and more water. So for the 3% proportioning, we have 97% water and 3% foam concentrate. And we keep this foam concentrate inside the tank. And when they pass through the proportioning device, it picks up the necessary amount of foam from the system and mixes with the water and sent to the discharge devices. These discharge devices are special equipment that picks up the foam and combines with air, and it finalizes with the foam. Not a solution anymore. The solution is water and concentrate, and then when you mix with air in the end with the discharge device, it becomes foam in final shape. So it becomes bubbles on the discharge device. And we have two important information which is makes the foam for fire protection is expansion ratio and drainage time. These are technical information that we have normally in our technical trainings, but it's important to know that this is not a normal soap, not like standard bubbles. These are tested with the fire situations in different fire scenarios and different applications, and they have a very special expansion ratio and drainage time that we call the stability of the foam. So you cannot use any soap for foam systems. So where do we use these foam systems? Typically in almost in all industrial plants that we have flammable and combustible liquids like diesels, like paints, like solvents, like the other chemical fluids that can be flammable and combustible. So when you have a fuel tank and it's burning, it's very hard to control its fire. So we have a system which is high performance with the foam system. We have foam tanks and a specialized center controlling the foam system. And it works as using the detectors in the system, flame detectors or fire detectors, informing the system that we have a fire in the facility. So in the related section, the deluge valve, as I showed you in previous slides, works, opens and sends the water on the pipe from the proportioner. And the proportioner mixes the foam in necessary quantity and sends out to the discharge devices over the tanks you see. And in the tank rim area, as we see, the fire is controlled very fast with the foam system in the related area. So these devices are specially designed for these kind of tank protection, and it has special items to expand the foam into a protection foam. And there is also some kind of dikes besides the tanks, and on top of the tanks, closed tanks, we have different devices like foam chambers that is expanding the foam in necessary amounts. And also in long distance throw, we have monitors. When maybe some of you have seen in the movies, monitors. And also in the loading racks and trailer areas, we have deluge sprinkler systems, foam systems. And also for the vessel protection in the piers, we have monitor towers with the foam systems. And also in aircraft hangars, we have different type of systems on floor level. On floor level, we have great nozzles integrated onto the floor of the hangar that eliminates any kind of flammable and jet fuel spill fires and controls the fire in a very fast manner. And also we can use monitors in the hangars. Monitors are automatically oscillating monitors like we have in the fields for watering the plants, but it's for fire protection. For also hangar protection, we have high expansion systems that's expanding the foam to almost 1,000 times of its original volume. So it's filling up some height in the hangar or in the storage rooms. And also the foam systems are used in the waste energy plants, waste storage plants, and there are special detection systems like thermographic camera systems that is pinpointing the fire point and directs the monitors to this position like robots. And in waste incinerator plants, we have big pits of waste going to the bunker and for the burning and energy production. And there are also installed electrical automatic monitors with thermographic cameras detecting hotspots and activating the system. So it's in general the applications of foam systems in different types of industrial and infrastructural facilities. And I will show another example with a deluge system, which is called high expansion systems. The operation of the system also will be a little bit explained.
In this scenario, we are looking at a Group 2 aircraft hangar. The hangar is protected with an electric release deluge foam system supplied by a bladder tank. A bladder tank is a device that is continually pressurized by the main water supply. The water sits between the steel shell and the rubber bladder. The bladder is filled with a foam concentrate. The bladder tank concentrate piping leads to the concentrate control valve that is held closed by priming water. The concentrate control valve is holding back the foam concentrate supply until the system is activated. Continuing past the concentrate control valve is the ratio controller. A ratio controller is a proportioning device that meters foam concentrate into a water stream to create a foam water solution, typically at a 3% ratio, depending on which foam concentrate is used. Upstream from the ratio control valve is the F1 deluge valve, which has a shared priming connection with the concentrate control valve. This allows the two valves to activate simultaneously. The deluge valve is holding back the main water supply until the system is activated. In a scenario where a fire has started in the hangar and begins to grow, the electric detection device activates and sends a signal to the VFR 400 release control panel. The electric solenoid valve is powered open, releasing water pressure within the priming chambers of the deluge valve and the concentrate control valve. The drop of prime pressure causes the priming line pressure switch to activate. Priming line pressure switches are required for factory mutual global approval. After the release of prime pressure, the deluge valve's clapper and the concentrate control valve's clapper open simultaneously. While the next steps happen in parallel, we're going to look at the water side of the system first. Once the deluge valve is open, water will fill the trim and activate the water flow alarm. Water will enter the system riser, passing through the ratio controller. Occurring at the same time, on the concentrate supply, the foam concentrate is under pressure in the bladder tank. Priming pressure on the concentrate control valve drops, and the concentrate control valve opens. Foam concentrate begins to flow towards the ratio controller. The foam concentrate will pass through the metered orifice and then mix with the water into a foam solution. Let's back up and show these steps all happening together as they would in a normal scenario. The foam solution travels to the foam discharge devices, and the fire is extinguished.
Yes, these are the foam systems examples, and the Deluge system working as a foam system, always in coordination with the detection part of the fire protection systems are very important for foam systems and gas systems. So at final subject, we have the different applications like gas suppression systems, also in working with detection systems. Where do we use the gas suppression systems? We can use the gas suppression systems in any kind of fire situation, but we have limitations of these systems because of their high budget, and we cannot use them everywhere because of some physical restrictions. But for the fires types, class A, class B, and class C fires in general, we can use these gas systems. So we have a fire triangle that consists oxygen, energy, and chain reaction, and the combustible material. And this fire triangle is also used to our the fire extinguishing mechanisms. One of these items will be critical for us to define our fire protection system. So when we use inert gas like argon, nitrogen, or their mixes, or CO2, we are trying to reduce the oxygen volume, oxygen rate inside the room or area below 13.6%. So when this happens, we don't have enough oxygen for the chemical reaction of fire. So we can avoid fire, or after fire starts, we can stop the fire by reducing the oxygen by using inert gases and CO2. And we have the other gases like FK5112, which is NOVEC 1230, and HFC227EA, like FM200. So these are also chemical gases, which are not inert gases. So we are using here, absorbing a lot of energy from the room, like refrigerating, cooling gases. So we are discharging these gases inside the room, and we are removing a lot of energy from the room. So the fire stops. And some other kind of gases which are currently banned, and it's forbidden to use these gases, were focusing on the chain reaction, and they were breaking the chain reaction, but they are harmful to the environment, so they are not allowed to use right now. So we use either inert gases and CO2, or the chemical gases that we call halocarbons or halochemicals. A typical gas system has cylinders and a pipe system and nozzles. And the cylinder has some portion of at liquid phase in general, the extinguishing agent. This is in general liquid, but sometimes in gas. For the chemical systems, the halocarbon systems, which has cooling effect, they are in cylinders in liquid condition. And we have on top of the liquid, we have the nitrogen to pressurize this extinguishing agent and direct to the room with pressure. And there is an electric release unit when detectors come gives a signal to the panel. The electric release unit is energized by the control panel, and the system activates and the gas is discharged. We still need here a detection system to operate this system. Let's see how a gas system works. This is a chemical gas system for protection of, for example, 2 rooms. One is a server room that has a lot of valuable devices, very expensive devices, and the data stored inside them, very important, and we cannot use water in that room. And the other zone 2 is the archive room, very important papers, and also here we cannot use our water systems in order to not damage important papers. So we have a room with the extinguishing system fixed with pipes and directional valves, each servicing to a single room. And when you see in the largest zone, we have detectors detected the fire with smoke, and it sends a signal to the panel, and the signal is also used to actuate the pilot valve, which is operating the other valves in the system. And by knowing that the first zone has the fire, we are activating the first zone activation solenoid. Or if zone 2 is activated, then the zone 2 solenoid is activated. So the detectors will decide which zone should be activated. In this case, this is zone 1, and the selector valve is opening, and or otherwise, if the zone 1 instead of zone 1, if the zone 2 gives an alarm, the zone 2 valve opens. When the zone 1 opens, the gas from the system is actuated by another pilot system, and it discharges just necessary amount of gas from the necessary number of cylinders. These are the main cylinders for the bigger room, zone 1, and the gas is going to the related zone 1. Or otherwise, if it was zone 2, the related pilot line activates the necessary number of cylinders, which is this time not 3 but 1. So it's a very small room. So it sends all the gas from one cylinder to the room automatically. And as you see now, the zone 1, the gas is discharged to the room and controls the fire. Or otherwise, if it's zone 2, it's only one nozzle and one cylinder, it's a very small room. It discharges the room in 10 seconds and it controls the fire. So these are all I can share today with you. I believe I showed you all different types of fire extinguishing system, fire protection systems, and their relations with the detection systems. It normally includes a lot of technical details, but I believe I clearly summarized most of the items. And if you have any questions, I will be pleased to reply.
First of all, I would like to thank you for your presentation. It's a very good presentation, also supported with these animations. They are so informing for us. Again, thanks for your sharings. And any questions from the students? So we have still time. The first question is from me, as the students are taking, I think, to give them time. The foam used in this industries, is that foam harmful for human body or human skin? or just like the soap, it is unharmful for us?
No, normally it's dangerous to touch this foam if you have any kind of exposure. Your hands, your eyes immediately should be washed at least for 10 minutes, because by mistake I touched foam concentrate which was diluted by water in 97% water and 3% foam 2 years ago, and I was having a glove in my hand. My hand was wet, and in the evening I changed my skin. One layer of my skin is completely changed. So in a few days, a little bit like a burn. So these kind of foams are special chemicals. We have also some environmental concerns, so we are changing our foam concentrates. All the manufacturers are working on changing their foam concentrates. They might be harmful to immediate exposure, but for the nature, we are changing it to non-fluorinated, fluorine-free foams. So, for example, the high expansion foams we use that you see in the animation, high expansion system in the last animation for the foam systems, these foams are already now fluorine-free. So you can dispose these to the natural waters, and it will not harm to the biological or groundwaters. So it's improving in the industry. We are improving for the safer and environmental friendly foams.
Okay, thanks for the answer. And the students, any questions? I can read it. Do wet systems have a water tank?
Sorry?
Do wet systems have a water tank?
Yes. Yes, the wet systems sometimes they are not connected to the water tanks. Sometimes, if you have, let me show you, if you have a reliable water supply, which is your city water line is reliable. If you don't have any problem with the water supply, you don't need to have a tank. But in Turkey, with the regulations we have, we need to have this kind of fire water tank in wet systems. In all fire protection systems, by the way, if it's a dry system as well, we need to have a water tank and a fire pump system, and it should be backed up at least 50% or 100% backed up. Not only one fire pump, but also backup pump also provided, because we don't have a safe water supply. So, but in Europe and in some other countries, in the USA, they can connect directly to the water supply from the city.
Okay, and the same student is asking about the capacity of the tank.
The capacity is defined by the system type. For example, for a car park, it's 144 square meters operation area and 5 liters per minute per square meter, and it's 1 hour operation time. So it makes 43 tons minimum, for example. That depends on the building type, what kind of systems you operate. If you have outside or inside hose connections. So these are all defined in the local fire codes, and we have the fire regulation in Turkey since 2002. So in the main fire regulation we have different type of calculations to define the minimum quantity of water tank. There are also some tables you can access from online free of charge. So you can check this table. It gives you minimum tank sizes for different types of buildings and different types of risks. I also have details to how to calculate them.
Thank you. And another question, asking that these systems are installed at the construction phase of the building, or can they be installed after the construction or after we get into the building?
For example, we have a system installed to a building which is almost 300 years old in Bosphorus. Currently, we are a system installed to a very old house. That depends on your system. So it was a water mist sprinkler system which has very small pipes, and the water damage is a very low risk. So these kind of systems can be installed if the facility lets us to install. You can install to a very old building, or we call it retrofit. So it's not a new building, it's already in place, and you should have special considerations when you are installing these systems in old buildings.
The voice.
Hello. You hear my voice now?
Now I can hear. A problem for the students, or did I only have the connection loose? Arkadaşlar sesimiz geliyor mu? Okay, they say no problem. So
okay, these are installed in all buildings as well, but it's a must for some special buildings to have fire protection systems installed. So it's also inside our fire regulations, and also each country has their own fire regulations.
Okay, thanks for your answer. And any other questions, guys? And I can ask a question. So the students are studying in mechatronics engineering department, so they are familiar with electrical side and also the mechanical side. Any job opportunities for mechatronical engineers in the fire suppression detection system sector?
Yeah, I know many people in different graduate levels. Some of them are mining engineers, some of them environment engineers, but I believe the most fitting education for fire protection engineering is mechanical and electrical engineering. So when we have some sort of combination of these two important departments, mechatronics is, I believe, the future of the fire protection. So the future, we have different kind of technologies like independent systems, automized systems, and there is more and more electronics and electrics involved in fire protection, like much more than ever before. So I believe in all positions in the fire protection market, we will need mechatronics engineers, especially in the technical roles like project managers and also some designers, consultants. So mechatronic engineering departments are quite easily adopted to our market. We don't have much colleagues in this experience, but I believe it's quite fitting education, and I suggest our friends in the department to investigate and focus on fire protection systems, and this market is overall all around the world probably the biggest industrial market, expanding market in the world. So the potential is big, the opportunities are big, and another importance is you are saving lives by designing or by supplying these kind of fire protection systems. basically you are saving lives and saving properties and saving money. So it's I believe besides earning your life from this profession, you have another satisfying information that every day you work to save some lives without actually going into fire, but designing or supplying these systems is another way of fighting fires. So this is my suggestions to my friends. If they are interested in doing something better than making a climate system or an air conditioning system or a central cooling system, the fire protection is something different and has, I believe, more and more value as an engineer. Okay.
Thanks for your sharings. I think it will be enlightenment for our mechatronical engineering students. And we still have time. Any questions from the students? Is everything clear? It's a new topic for you. One question, let me check it. Do you have any projects? Do you have any projects that you want to implement in the future?
Yeah, you are. We are currently working on at least 5 or 6 projects every day. So I couldn't understand.
And what's your aspect? What would you like to ask? We didn't get the projects or new technologies or project of a building. Can you re-ask it? And waiting for other questions. Maybe 4, 5, 6 more minutes. We can wait and have the questions. Bayram Ali Özçelik, do you have any questions? Bayram Ali, sesim geliyor mu? No, okay na. Ceyda Biber, any questions or anything you would like to add? No, sir. Okay. And the last one to pick, Yiğit Özcan. Any questions? Yiğit, you hear us? Malik asked about the maintenance periods of that systems.
Yeah, in the standards we have, according to the location of the project, we have different standards, but in widely preferred standards like NFB 25 or EN 12245, 12845. These are the standards that we base our maintenance schedules. So these maintenance schedules include weekly maintenance, like the operators inside the building, the owners are responsible for. They have to check kind of gauges or measurement devices on the system. Maybe weekly pump test they have to make it with their technical persons. And for the quarter-based, I mean in 3 months, there are also some checks to be done by the technical person of the facility, or if they are not able to do it, they need to hire a company, a specialized company, to make the maintenance for 3 months. And especially for the every 6 months or every year, there should be an expert company, fire protection maintenance company, should come at least once or twice per year. They should make a general maintenance that is described as in the standards. So these are, of course, the maintenance minimum should be done by an expert company once per year or twice, and every week and every quarter by the owner of the building. So they need to keep the system working every day. This is the maintenance.
Okay. Okay, it's a very important issue because you need system working maybe only once whenever you need. It would be very sad to understand insurance companies want you to check the maintenance, do the right maintenance of the systems to make your company or your property have insured. And last chance, any questions from our students? Anything you would like to ask? In Turkey, are the companies taking it serious? Is there maybe the facilities, industrial facilities?
Yeah, the industrial facilities so and also big commercial buildings.
About the maybe more.
You hear me?
Yeah, I can hear you. Okay.
In most of the projects like industrial plants, big commercial buildings, hospitals, etc., big public buildings, there is a must. There is a fire regulation, and the fire regulation requires up to, from some level of height of building for high buildings, for high storage, for a big usable area of for example, a shopping center. You need to install fire protection systems, fire extinguishing systems, automatic ones, and at least manual types of fire protection, kind of extinguishers, manual extinguishers, or kind of detection systems are must on the other buildings which are not specified with automatic extinguishing systems. So there is a regulation. We have a Turkish fire code. You can access from the government newsletter from the official website of the government letter, government newspaper. So you can find
it. And from me, you in foam addressing monitors for the ships, and can we see that kind of monitors in the shipyards or customs? Or I haven't noticed before.
Monitors in the shipyards?
Yeah, we saw in the video some monitoring towers for the ships. And is it possible to see some examples in Turkey? Because I haven't noticed that towers before. Maybe my bad.
These are in general for the fluid terminals, like fuel transfer. For example, in kind of refineries, for example, the refineries are filling in refined products like petroleum, white products, we say, the gasoline or diesel oil. These are a little bit more flammable than the crude oil. So you have to be careful when transferring these from the vessel or to the vessel. So if you are inside a refinery, you will see these.
Okay.
A lot of them. If you are visiting a liquid terminal, like we have Polyport in Kocaeli or Safi Port, kind of big tanks, Yılport, let's say. These are kind of, when you go by the road, these are big tanks, and they are keeping sometimes flammable liquids. And there you will see between the tanks our monitors. remote controlled by electric remote controls, like a robot from a high distance. So these kind of installations you need to look at in very detail to see.
Okay then, and if there is no more questions, I would like to thank Mr. Yusuf ARSLAN for his brief and very attractive presentation. So the last words on him, and after that I'm going to close the session. So Mr. Yusuf ARSLAN, for a closing speech, what would you like to say for last words?
Yeah, thank you very much for your patience, and I hope I conveyed the necessary information. It was a pleasure to be a presenter as a lecturer, guest lecturer by the name of TÜYAK. As a member of TÜYAK, I suggest my dear friends in the department to check TÜYAK activities, and we are not making any room activities right now, like exhibitions or seminars, but I hope we will see nice big events in after the pandemic gets in control. So we will have, we would like to see our young friends in our activities, and also they can be student members, and they will be in, checking in our organization regularly, and I suggest them to work on our fire protection systems area of expertise, and it's a good area of for an engineer from my experience. So thank you very much giving me this chance to explain about fire protection systems, and see you next time.
You're welcome, and again, thanks for your presentation. Hope to see you in our future semesters. And now, time to end the session. Good night, everyone. See you. Take care.
Goodbye.